Alright, on the properties of logs, we've got three major properties. We did use these in Algebra 2, so they won't be completely new for you. The first one that we're going to write here is the product property. What we know about the product property when we're using it with logs is that it's friends with addition. So if we have something that's written as log base b of x times y, xy means x times y, that's a product. We're going to rewrite that as the log base b of x plus the log base b of y. Okay, because what you'll be told to do with this kind of stuff, and it's the same as you were in Algebra 2, you'll be told to expand or condense it. This first one here, it's written with just one log, so we wanted to expand that to as many logs as we can. Or they'll give you more than one log, and they want you to condense it back to just one. So that's all you're going to be doing with this stuff is rewriting. Okay, that was your product rule. The next one after product rule is your quotient rule. And what we remember about quotient is that it's friends with subtraction. So if I had, this here, log base b, quotient means division, so x divided by y, that's going to be the same as log base b of x minus log base b of y. Okay. Then the third is the power rule. Power means we got a power or an exponent, however you want to say it. If we had log base b of x to the r, a power comes down in front of the entire log. So this would be the same as r times the log base b of x. You just bring the power all the way down to the front. Alright, now these can be used one at a time, or you can have a problem that's got all three of them in there multiple times. Just different ways to look at it. Alright, let's start with an easy one here. Everybody got that? This one says log base 7 of 4 times 5. It says use the properties of logarithms to express each logarithm as a sum or difference of logarithms or as a single number if possible. Assume that all variables represent positive real numbers. So lots of directions on that. We see we've got multiplication. Answer to a multiplication problem is called a product. So you ought to know you're using the product rule. Product is friends with addition. So all we're going to do is take this we're going to take the log base 7 with each piece here. So I'm going to have the log base 7 of 4. And then we look at our rule and we remember that product plus she goes with addition, so plus. And then I got to do the log base 7 with 5. And that's as far as you go on this. I just wanted you to rewrite it. Yeah, you could actually figure out that. Because we've got that log base button in our calculator. We could go and do log base 7 of 20 and get an answer. But that's not what it wanted us to do. It just wanted us to rewrite it. Okay? Everybody alright? Let's do some with variables so you're not as tempted to try to solve it. This is a good one here. Log base 3 of the cube root of 4 over x squared y. Alright, we're just kind of jumping in with both feet on this one. There's lots of stuff going on. First off, that's a cube root on the top. That's an ugly 3, hard to read. But you have to know that the cube root is also a power. What power is the same as cube root? 1/3 is exactly right. So I'm going to rewrite that. You can skip the step, but I'm doing it for you. That's the same as 4 to the 1/3, because remember, power over root. Alright, so now you should notice you got that division. But what's super important, and a lot of people will miss this, that 4 1/3 is being divided by both of these. Isn't X squared and Y both on the bottom? And division is friends with subtraction, so that means I'm going to be subtracting both of those. And that's where a lot of people will get wrong on this. So I'm going to write this as, going some baby steps here, log base 3 of 4 to the 1/3 minus, and I have to subtract both of these pieces on the bottom with a log base 3. So minus log base 3 of x squared minus log base 3 of y. Now that got you a good jump and you're almost done. What can you still do here?
Bring the exponents.
Say that, yes. Those exponents, and that one I wrote kind of crazy. It almost looks like I lost it. Power rule says you bring your powers to the front. So now this will be 1/3 times the log base 3 of 4 minus 2 times the log base 3 of x minus log base 3 of y. So that whole shebang there is your answer. Good job, Leah. So we didn't have to do any math on that. I hadn't figured anything out. I just used those properties to rewrite it. Now eventually, I don't know if it's today or not, I don't know, we'll have to look and see, but eventually you'll get to where you need to be able to do that to solve something. So that's the whole point in it. Let's try another. I got the log base 2 of the cube root of x times the 5th root of y all over r squared. I'll let you see how far you can get on that one. Remember the cube root and 5th root, those are powers. You got to rewrite that as a power. Think you got it?
I don't know if mine's right.
Alright, well all I've done so far is took the radicals out and put the powers in for that. Cube root is the same as the 1/3 power, because it's the first power over cube root, power of root. Fifth root is the same as the 1/5 power. So that's all I've done so far. Now what Katie asked me is on the top, this is multiplication. Multiplication is friends with addition, so I'm going to start with that. I'm going to say that's the log base 2 of x to the 1/3 plus log base 2 of y to the 1/5. Okay? Now I'm not done with that, but I am done with the top for right now. So I'm going to go ahead and go, when I get done with the top and I hit this bar right here, what sign do I got to go with? Subtract. Very good. So minus log base 2 of r squared. Very good. That took care of the product and the quotient property. Now every piece of that has got a power property to go. So I'm going to bring the 1/3 down here. I'm going to bring the 1/5 down here. Will you get that, Shelby? I'm going to bring the 2 down here. Okay? So that'll give me 1/3 times log base 2 of x plus 1/5 log base 2 of y, and then minus 2 log base 2 of r. Everybody get it? Mr. Withers said he wants us to keep keeping the doors locked just because it's a good thing with him.
Miss Davidson is always
I've always liked the idea, but then he's complained about it. Guess he changed his mind. Alright, so far all the ones that we've done, we've expanded. I want us to go the other way now and condense. So, if I had, let's see, let's find a good one. 3 times the log base a of 5 minus 4 times the log base a of 3. And we're going to condense this one. Here's how the directions will sound, all wordy and everything. Use the properties of logarithms to write each expression as a single logarithm. Means we want to get it down to just one log, a single logarithm. So, when we did the expanded ones a second ago, we saved the powers for last. But now we're doing condensing, so we're going to go opposite. We're going to take care of the powers first. Both of these have got a power because they both got a number down in front. So this 3 is going to have to go to a power on that 5. And this 4 is going to have to go to a power on that 3. Okay, so it's going to give me log base a of 5 cubed minus log base a of 3 to the 4th. Okay, I still have 2 logs. I'm trying to condense it to 1. What goes with subtraction? Quotient. Very good. So it'll be log base a, and you put the first one on top and the second one on the bottom. Now you do know what 5 cubed and 3 to the 4th is, so you could simplify that. Let me check my directions and see if they wanted me to here or not. Number 27. Yeah, they did, because it didn't say. I mean, I would count it right either way. But here would be your clue. You know your test is going to be multiple choice. If that's not a choice, then go ahead. 5 cubed is 125. And 3 to the 4th is 81. So either one of these is correct. You do whatever you have to do to find the right choice on the test. Okay?
Even if it means cheating.
Whoa. Did not hear that from me. Alright, let's try a bigger one of those now. I got that one? Alright, here I've got 3 log base p of x plus 1/2 log base p of y minus 3/2 log base p of z minus 3 log base p of a. Alright, 3 about the biggest one you can see on this. Notice, by the way, that all of these are always going to have the same base. Those properties only work if it's the same base. All these are log base P. If I had a log base P and a log base Q, I couldn't use the properties. They got to have the same base. Okay? So let's start here with your powers. So take all your powers to where they go. So I'm going to have log base P of x cubed. And you'll be able to skip some, do more than one step at a time, but I'm just doing it baby steps with you right now. Alright, I got my power property taken care of. Now, you're just going to work left to right on that addition and subtraction. Remember that addition is multiplication and subtraction is division. So, first off right here, I'm going to have log base P of x cubed times y to the 1/2. That took care of that addition piece there, right? Are you okay on that? Now remember that earlier problem that we did when it was all followed with subtraction? That meant it was all being divided. So if both of these end pieces are being subtracted, that means they both came from division, so they're both going to go on bottom. So I'll put a z divided by a z to the 3/2 and an a, I wrote 3/3, 3/2 and an a cubed. And that'd be it on that. You could, if you know, like that y to the 1/2 is the same as the square root of y. I wouldn't, this is a time when I wouldn't do that though, because if I changed one power to a radical, I would want to do both of them, and you can't leave a radical on bottom. So, wouldn't really, I'd probably just stop there. That is the way the book stops, so that's the way it would be on a test. Alright, I got a couple more things to look at. You're doing good. Everybody done with that page? Alright, I got log base 2 of 8 plus 32 is equal to log base 2 of 8 plus log base 2 of 32, and it's true or false. So, true or false? Okay, Leah says false. What does anybody else think? Devin thinks true. Katie's maybe thinking.
One is false because they have to be multiplied.
Okay. Alright, if we look over here on this right side, if I rewrote this right side, condense that to one log, that would be log base 2 of 8 times 32, because addition goes with multiplication. This one doesn't have multiplication. So nice job, you false people. Alright, let's do another true false one like that. See if I can find you a hard one. How about log base 3 of 8 is equal to, or not, I wrote the problem wrong, plus, sorry, I'm a stupid, plus log base 3 of 1/8 is equal to 0. Alright, last week at some point we talked about some special scenarios where things worked out, like if something to something was always equal to 1, that kind of, so that's what's going to come into play here. Let's go ahead and start seeing if we can rewrite that stuff on the left side to see what that would get us. This is addition, so it would be log base 3 of 8 times 1/8. And what's 8 times 1/8? 1. So log base 3 of 1 is equal to 0. We talked about these special scenarios last week. Because remember, this is in log form. If we rewrote this in exponential form, it would be 3 to the 0 is equal to 1. Remember that? Going from log form to your bin form. I know last week was a long time ago, but that was one of the things we talked about. So anytime it's equal to 0, your exponent is 0, your number always has to be 1, because anything to the 0 is 1, right? 7 to the 0 is 1. So anytime your exponent spot is 0, your number always has to be 1. Does 3 to the 0 equal 1? Yes, that one would be true.
So shut up. I think I spaced out. I'm so confused.
Okay, you're good, because Bailey just asked a question too. Anytime because we got log base b of n is equal to e, that's your log form, and your exponential form is base exponent equals number. So
Okay.
if your exponent is a 0, anything to the 0 power always equals 1. Remember that? You can have 10 to the 0, a to the 0, anything is always equal to 1. So if you have a 0 in this spot, the number has to be 1, because it's equal to 1 there.
Okay.
So you just change the form and it equal itself? Okay.
Okay.
I actually have 2 days off.
All right.
Not worked 8 days. What? My next paycheck's gonna be like $600 bucks. And my taxes will be in supposedly by the end of the month. And it's direct deposit, so I can pretty sure.
All right, one more true false one here. Log base 10 of 7 divided by log base 10 of 14 is equal to 1/2. True or false? All right, well, first off, we need to use the quote. That's division on the left side, so we need to use the quotient property to rewrite that, right? So that would be log base 10 of 7 minus log base 10 of 14 equals 1/2. All right, so what are your thoughts on this so far?
It works.
Say what now, Willis?
It looks like it's true. It's 614.
Right, and that's what they're wanting you to think on this. If you look at the top, you know that 7/14 is 1/2, and so people are going to say 7/14 is 1/2, log 10 will cancel out. But down here, when we rewrote that using the quotient property, what's the log base 10 of 7? 10 to the what power equals 7. Okay, and then you got the same thing over here, 10 to the what power equals 14. So that's what keep writing stray marks everywhere on it.
I was about to say, what did you do?
That's what you're actually figuring out, is when you subtract those two values, do you get 1/2? Okay, so how can you figure this out? Because that's obviously not a whole number. 10 to the first is 10. It's got to be smaller than 1. So how can you figure out what log base 10 of 7 is and log base 10 of 14? Type it in your calculator. So hit log base 10 of 7 minus log base 10 of 14. See if you get 1/2 or not. Now go back to that. Down. Alright, I was waiting on Katie to finish that For her log base 10 of 7 minus log base 10 of 14, she got negative 0.30, and it keeps going. Is that equal to 1/2?
I mean, if you add a few of those.
Yeah, a few. That's one of those that's kind of a nasty trick problem. Because I'm like Devin, when I first look at it, I'm like, well, yeah, 7/14 is 1/2. But when you start taking the log of those numbers, that totally throws you for a loop. Alright, so not a whole lot of real math involved in your properties. It's just rewriting stuff. The next lesson that we look at tomorrow is called common and natural logs. Natural log is where you get the LN. Remember that LN button that we used a little bit in Algebra 2 that has a base E? Craziness, the number E. The number E. Yeah, so that's the stuff we'll be looking at tomorrow. Alright? Nice job. Oh yeah, the juniors won't be here. You'll be missing on the number E.